Hi, so to start off, the name of our project is the Statistical Analysis of Baseball by Carmine and Nicholas Wolf. Starting off with slide number 2 of our project is our overview. Um, we did baseball statistics in 2010 by looking at a total of 30 teams. Um, Throughout all the analysis, it demonstrates the aspect that leads to the wins of the teams, such as how much money they're putting out, um, what league they're in, and a couple dummy variables that are actually in the project. The real world connection that we can pull from this, it can help teams lead to more wins. For example, kind of how like football works, and Bill Belichick of the Patriots has a certain way of picking players, and Alabama coaches, Nick Saban and stuff, they pulled away from that. It's just kind of like a real world connection between the two. And basically, baseball players and baseball teams and managers can use this analysis to help find strong variables of picking teams and making a winning organization. Um, the Y variables that we were given were the number of wins. Um, it is the only dependent variable, and all the X variables determine the number of wins. The X variables that we went through is the ERA, the batting average, the home runs, stolen bases, errors, built, which is the year that the stadium was open, the size of the stadium, the attendance, which is in the millions, um, payroll, which is average player salary, which is also in the millions. All of these are all independent variables. So basically, throughout the project, we pulled away 3 different hypotheses. One is that the pitcher with the lower ERA rating will help their team win due to the fact that they will cause the other team to have less runs. Also, by having a better batting average, it will give the team a better chance of winning because they're more likely to have a chance of scoring runs, hitting doubles, triples, basically getting guys on bases and scoring. Um, our final hypothesis was home runs will also greaten the chance of winning because it is more scores for that team. Basically, they'll be able to hit home runs and just score no problem and have runs scored easily and outscore the other team. Statistical tools that we used, we focused on ERA, batting average, and home runs. Um, those were the 3 that we mainly focused on. And then the tools that we actually used, that would be scatter plots, t-tests, p-values, and confidence intervals. So basically that wraps up all of my 6 slides. Next, Carmine's basically going to go into about scatter plots, why the X variables were significant, what they were, also about what we learned, and the real world implications of all this, and kind of what it taught us throughout this entire project. So that's it.
Hello, my name's Carmine and we're going to pick up where Nick left off, and we're going to be on slide 7, and we're going to talk about the scatter plots. So for the first scatter plot, we have wins versus ERA. The x-axis is going to be the ERA, the y is going to be the wins. So when we look at our data, the points, we added a trend line, and it showed that the slope of the graph or the plot is negative, and we concluded that it is nonlinear, considering that they show more of an inconsistent linear line. And then if you go to the next graph, next plot, it's going to be wins versus the batting average. Batting average is x-axis, the y-axis is wins. When we added the trend line, it showed that the data is positively sloped, and it also isn't nonlinear, or it is nonlinear. Then you go to the next slide. Is the next scatter plot. We have wins versus home runs. The x-axis is home runs, the y-axis is wins again, and the trend line shows that the data points are shown in a positive manner, but we also concluded that it is nonlinear. Then we go to the next slide. So what x values or x variables were significant? So we did 3 tests: the t-test, the p-value, and the confidence interval. The t-test showed that all 3 variables were shown to be significant because the absolute value of all the values were all greater than the critical value. For the p-value, the batting average and the home runs were significant, but the ERA wasn't. This was found because the values that were below 0.05 were shown to be significant. And lastly, the confidence interval, all 3 were significant because none of the values would pass through the number 0. Now we move to the next slide. Some things that we took away from this data project is that statistics can be applied to almost anything. A lot of things around you in the world could be applied with statistics. Many businesses, many organizations. The second thing we took away is that there is not always just one x variable. Previously, what I've thought before, and my partner, we always thought that all y and x variables, there's only just one. But through this project, we learned that there's multiple x variables that can be found in multiple different things. And the third thing we learned is that it can enhance the way we look at statistics in sports. Before the project, we wouldn't know that statistics were a big part in sports like baseball. But after you look at them through this project, they can lead to success to many teams if they're used the right way. So a real-world implication could be, for example, if you had a fencing company, the y variable would be the profit from the company, and other x variables would be inflation rate, the cost of materials, employees, the customer satisfaction. And one thing that happens in the world depends on multiple things such as cost, quality, and quantity. It will also help us with our future jobs, like if we are a business or financing major. It could show us the gram scheme of how statistics and variables work in the real world. Now, that's the end of our slideshow. If you have any questions, shoot us an email. We'll be happy to respond to them. If you don't have any questions, we hope you have a great day and stay safe.